CPM Math 3, problem 1-60. We're being asked to graph and completely describe this exponential function, f of x equals 4 to the x power. So I've kind of started a table here, and let's see what happens if we start to input some of these numbers. Don't be afraid of some negative input values. Let's see what happens. We get f of negative 2 equals 4 to the negative 2 power. Well, that is just the same as f of negative 2 equals 1 over 4 squared, which is 1/16. Yes, that's a small number, and we'll have to figure out how to graph it, but we can do it. It's not a big deal. All right, so let's do f of negative 1 equals 4 to the negative 1. So f of negative 1 equals, that becomes 1 over 4 to the first power, or just simply 1/4. All right, let's fill in a few more of these. Okay, so after putting in a little bit of pencil lead and finding a pattern here, I actually noticed that it's a pattern of multiplying by 4, and that kind of helps. All right, so let's start plotting some points. Negative 2 comma 1/16. Oh boy, that's going to be like rightish there. Negative 1, 1/4. 0, 1, and just to point out that anything to the 0 power, like you see right here, is 1. Mathematically, it has to be 2. 1 is 4, and 2 input of 16. Oh my goodness, that's way, way up here. Okay, so what we have here is a graph that's going to go like it's going to grow like super crazy fast, like that. And that, I disconnected that. Oops, a little messy, but we get the idea. Okay, so what we're being asked to do then is to completely describe. All right, so you want to describe the shape as exponential. Alrighty, we want to describe the domain and range. All right, our domain is all possible x values, and we can use all x values that are, actually, we can use any x value. All right, so let's just say all real numbers. I can use any possible domain. For a range, however, I'm never going to hit 0. There's no way to get 0. So our y values are all going to be greater than 0. We do even have an asymptote, and our asymptote is at y equals 0. And what else can we say? It is a continuous graph. Continuous, and it is a function, and I'm sure I'm missing something. Oops. It is a function, and I think we're good to go.